these three special products. Okay, we have more than three special products, but at least these three, and I'm hoping that we don't have to go back and review these again. Okay, so I'm going to stop sharing and just talk quickly about these three. So can anyone tell us what will this equal to and what is A plus B? How do we call it? Just to go back to a little bit of a terminology. Anyone remembers?
Doesn't that make A squared plus 2AB plus B squared?
Thank you very much. Okay, so can I call you Colby?
Yes, that's fine.
Thank you. So if anyone prefers a nickname or something else that you would like me to call you, I will definitely write it down. So thank you so much, Colby. Colby did this. He said this is a binomial, two terms. And when we square binomial, he said basically that this has to equal a trinomial. So two terms added, squared, will give us a trinomial, three terms. And obviously, if this is minus in the middle, this will be minus. Anyone has any questions on this? Anyone needs any proof? Don't be shy. It's okay if you say I don't remember or I need help or something. If not, I will move on. Okay, so in that case, let's look at an example, simple one, like 2x plus 3y, 2x squared plus 3y, everything squared. Yes, you can put them side by side and FOIL, but we want to stay away from that. My students in the beginning algebra can do that. But in calculus, I highly recommend let's use the formula. What does the formula say, right? The formula says first term plus second term. First term plus second term, everything squared. First term, second term, everything squared. And this is first term squared plus twice times the first term times the second term, and you will always realize that because I write so big, I always run out of room. And these are not two pluses. This plus says look for where it follows. It's not plus plus, right? If I don't write something here, you may think that it ends there. But if I put a symbol, you look for the symbol and continue. But they're not two symbols. It's just one. So can anyone give us the trinomial that we have to write? Anyone other than Colby, because he already proved it, that he understands this.
Would it be 4x to the fourth power plus 12x squared?
2 times 2 is 4. Very good. So you can write it. Yeah, that's 4 times 2 is right. So 6 and 12. Correct. 12x squared y. Very good. And plus
9y squared.
9y squared. Thank you so much, Katie. That's perfect. Anyone has any problems with this? And the last one I wanted to review is the difference of squares. Anyone remembers other than Katie and Colby? That's how I learn your names. Anyone would like to tell us what this equals to? Anyone else?
A squared minus B squared?
Thank you, Sidra. Am I correct pronouncing your name?
Yes.
Thank you. Okay, so this is the difference of squares. So notice that these two have to be the same except the symbol in between. And of course, you can write it either plus and minus or minus and plus. It doesn't matter. So can anyone give us an example so we can illustrate this and move on? Make one up. Other than Sidra, Colby, and Katie. Anyone? Yes, Lois? You wanted to say something?
Can you hear me?
Yes, I can now.
Oh, okay. So did you want me just to use different letters or like plug in numbers? Because I was thinking 7 plus 3.
But
And
that's but 7 plus 3 is not.
Right here. You're right.
Say it again.
No, so I guess 2x plus y
Okay.
and 2x minus y.
Yes, that's it. So and the answer would be
2x to the squared minus y squared.
I agree with y squared, but the first
4x
one would be
4x squared.
I agree completely. So notice that the difference of squares is exactly what it says, the difference of squares. Okay, so thank you very much. And I think we have enough of that unless you have questions. Anyone? Okay, so now let me share my screen. I didn't mean to offend you with this, but I get in the middle of the semester questions like, where does that 2 come from? So I'm trying to avoid that if possible. Okay, so now I would like to look at the skills assessment. And I would like you to click on it, on the template. Again, you don't have to print it out, make up your own, but it has to be exactly what you have in WebAssign. And I'm hoping you're going to sign up as quickly as possible. Okay, so look at this and just say, I would like to see this or I would like to see that, because I don't know where you are or I don't know what you need. And then maybe we can hopefully start chapter 2. Does that mean that we understand and we know all these? That would be awesome.
Can we see number 6, please?
Number 6.
Thank you.
Very good. So in number 6, let me copy it. And we have y equals e to x plus 2 minus 3. It's a very good point, very good example, very good problem. So we do have exponential functions with base e, which the exponential function is called natural exponential function. And that is e to the x. It's a very important function. We should immediately understand and remember its graph right away, and also domain and range, and also something called limits. Let me just push my device a little bit further. Okay. So now here is the graph. It's a function that tortured us for what? Almost 2 years. Okay? It's a function that we've been trying for 2 years to flatten the curve, they say. But it was just a terrible function. I never said I never thought I would say that, right? Bacteria, viruses, that's what I'm referring to, etc., follow such an exponential function with a base greater than 1, which has the fastest raise and increase as you see it. We've been trying for 2 years to do this with it. It didn't work. Still doesn't work. Okay, so this is a function that always crosses at 0, 1. Why? Because when x is 0, y is 1. It's an increasing function because the base is greater than 1. And as you see, the domain of this pure exponential function, domain, is all real numbers. But for the pure exponential function, the range is different, right? Because if I have some transformations in it, the whole thing changes. The domain will never change of the exponential function, but the range will change. So as you see, it has a horizontal asymptote, y equals 0, and it's always increasing. So the domain, negative infinity to infinity, and range, open 0 to infinity. And it has a horizontal asymptote, y equals 0, horizontal asymptote. Okay, so now why did we discuss this? And as you see, as x approaches negative infinity, let me do this with two different markers. As x approaches infinity, the function values get closer and closer, closer and closer to 0. So that will eventually be our limit for later. And as x approaches infinity, unfortunately, this function blows up, we say. It goes to infinity. So why did I refresh your memory on this? It's because that's what we are trying to do here. So e to the x is this graph. E to x plus 2 will be a shift. Anyone remembers, first of all, where will that shift be? So e to x plus 2 is a shift. Where? Anyone remembers where?
Is it to the left too?
Excellent. It is, who was that? Chris? Thank you. Left 2. How do we know that? Well, in general, I don't like telling my students, memorize this, memorize that. I need to explain. But for this function, it's slightly more difficult to explain why it goes to the left than to the right. But I can explain quickly on, let's say, the square, x squared, let's say. So we know that this function looks like this. This is our x squared. But if I want to determine another function or graph another function, f of x, which is x plus 2 squared, Chris said shift to the left. How do I know here? Very simple. Because this is the x-intercept, right? When x is 0. Where will this have the x-intercept? Of course, when x is negative 2. So that's why the shift is to the left. Slightly more difficult to see for an exponential function. Well, what about x minus 3? Well, of course, x minus 3 will be a shift to the right because now the function will have the x-intercept at 3. So this is to the right. This is to the left. Good, so it is left 2. And then down 3. So using transformations, and let me write here the last transformation. And then e to x plus 2 minus 3 is down 3. Okay, so also I would like to refresh your memory on how do I know that this is a shift to the left or not up? How do I know that this is a shift down and not to the left or right? Well, it depends on whether the transformation is on x or on y. So bottom line, the graph will be step by step. This is always, so please always remember, when we're asked to graph a function, we have to establish domain. We have to find x and y intercepts. We have to find the range. And this is, in this case, if I use transformation, this is not required. But if I don't use transformations, I have to have a table of ordered pairs. Okay? So first I will graph the original or the base function. And this is e to the x. Then you told me, Chris did, to shift, oh, this is not a good color, to shift this graph to the left 2. So this point shifts to the left 2. It was at 0, 1. Now it is at negative 2, 1. So this is the graph of e to the x plus 2. Both these two graphs have a horizontal asymptote, y equals 0. Now, when I have to shift down 3, first, I have to shift the horizontal asymptote first. 3 units down. And then I will take this point and move it 3 units down. Before I do that, let's draw the horizontal asymptote. It's not part of the graph. It will not be a solid line. And now before of course, I do know that this point is right here. No questions asked. Absolutely. 1, 2, 3. I know the graph looks like this, but I don't know where it crosses the x-axis. I don't know where it crosses the y-axis. I cannot just blindly put something in there. I know the domain of this function. So domain, negative infinity to infinity. It's a friendly function that way. I do not know the x and y intercepts yet. I will in a minute. The range is very clear. What is the range? Can anyone give us the range?
-3 to infinity.
Very good. Awesome. Who was that? Rachel?
Yeah, Rachel.
Thank you very much. Thank you. Okay. And finally, so this is done. This is done. The table is not really required in this case, because we are using transformations. But I have to find the x and y intercepts algebraically. How do I find the x intercept?
By replacing x with 0.
Very good. So here I have f of x equals 0. So then I have e to x plus 2 minus 3 equals 0. How do we proceed? How do I solve something like this?
Well, do you mean like put it into the calculator? How do you do it? Or do you mean like after putting 0 in there, what do you do?
Yes. What will be my next step here?
We'll replace x with 0, so that would just be e.
This was here.
2.
We're not talking about that.
You meant the y-intercept, sorry.
So f of 0, I agree. So it will be e to the second power minus 3. Am I missing someone? Okay.
For the x-intercept one, add 3 to both sides first.
Very good. E to x plus 2 equals 3. And now?
I think take the natural log.
Very good. Apply natural log to both sides. And remember the natural log rules, or any log. A power goes in front as a factor. How much is natural log e?
1.
Very good. So then this will be natural log 3. So x will be -2 plus natural log 3. Okay, I'm going to share my screen. If I can find my mouse, it's all over the place. Where is it? Okay, got it. Okay, so -2 plus natural log 3. Here it is. Approximately, x approximately -0.9. And I also want e squared minus 3. And that's 4.4. Okay, so I found the ordered pairs. So y0 when x is -0.9. And x is 0 when y is 4.4. 1, 2, 3, 4, 5, 4.4. Here's my graph. So I'm gonna do this so everyone can see that this is the final graph. And that is e to x plus 2 minus 3, and that's f of x. Any questions on this?